In this question, we're going to have a look at how these three rules in year 2 probability can be used along with drawing out Venn diagrams to help do parts A, B, C, and D of this question. So it's given us the probability of A, B, and A given B. It's asked for the probability of A intersect B. So straight away, let's have a look at if we can use one of the formulas. So because it's given us A given B, and it's also given us B, we can rearrange this equation here to get A intersect B. So we can say it's equal to the probability of A given B multiplied by the probability of B. So let's do that. The probability of A given B is 1 over 4, and you can multiply onto that the probability of B, which is 1 over 2, and that's equal to 1 over 8. Moving on to part B of the question. So with given that questions, I'd always recommend you break it down using the equation to start with. So not B given A. In this case, we replace everywhere where there's A with not B, and everywhere where there's B in this expression with A. So it will be the probability of not B intersect A, all divided by the probability of A. But how do we know the probability of not B intersect A? That's where step number 2 comes in, where you draw out a Venn diagram. It'll help you visualize things a lot better. So with drawing out Venn diagrams, I'd always recommend you fill in the center first and then go outwards. So the center is intersection, which we already found as 1 over 8. The probability of A is 5 over 16, but that includes everything in the circle of A, including the middle. So this plus this is 5 over 16. Now if we do 5 over 16 minus 1 over 8, that will be 3 over 16. So that's what we put exclusively in the only A section. Using a similar idea, the probability of B, which is this plus this, is equal to a half. A half take away an 8 will be 3/8, so that's what we put here. And then outside of the two circles, but still inside of the Venn diagram, is what we put 1 take away this, this, and this. So adding these together, I'm just going to quickly do that in my head. So this is 2 over 16, this is 6 over 16, so they add to 8 over 16, plus 3 over 16 is 11 over 16, meaning there's 5 over 16 left over, and that has to be on the outside in order for everything to add up to 1. Now, the probability of not B intersect A. Actually, I'm going to show you a little method for this, something that I created myself actually. Not B is everything that's not in the circle of B, so that's this and the outside. In a different color, actually we can just use a vertical line, but the section of A is everything in the circle of A, so that includes this and this section here. Now, where I've shaded in twice is where they intersect. So if you see, I've shaded in twice here, meaning the intersection of not B and A is just 3 over 16. So we can say 3 over 16, all divided by the probability of A, which is 5 over 16. And that's just equal to 3/5, which is the answer to part C of this question. So let me write that out here. And then we can write equals 3/5. So it's good that we draw out the Venn diagram because it's also going to help us with part C of this question, where it says not A union B. So in one color, let's shade in what section of the Venn diagram is represented by not A. That's everything that's not in the circle of A. So that's this and this section. In a different color, let's shade in what's represented by just B. So B is everything in the circle of B, so that's the middle plus this section here. Again, where the two colors intersect is where I've shaded in twice, and where I've shaded at least once, so like this middle section, this section here, plus this end part here, is in the union. So we say it's just the sum of these three probabilities, which actually adds up to 13 over 16. Moving on to the last part of the question, it's asked whether A and B are independent. So that's where we use this rule here. If we manage to show that the probability of A multiplied by the probability of B is equal to the intersection, then that shows that they're independent. So let's do that. The probability of A is 5 over 16, and if you multiply onto that the probability of B, which is a half, that's actually equal to 5 times 1 is 5, and 16 times 2 is 32. Probability of A intersect B now is just 1 over 8, and that's not equal to 5 over 32, because this is not simplified to 1 over 8. That shows that events A and B are actually not independent. So that's what you'd write as your final statement there. If you want it to be a little bit extra, you can also say because probability of A times probability of B is not equal to probability of A intersect B. But hopefully that will make sense. That's how you deal with questions like this. you either use the formulas or you draw out a Venn diagram and use the formulas. Hopefully that will make sense, and please like the video if it helped, and be sure to subscribe.